Write down in your notebooks your answers. Number now itself, 31 to 36. Yeah.
That is the end of Part B. Now look at Part C. Part C. In this part of the test, you'll hear two different extracts. In each extract, you'll hear health professionals talking about aspects of their work. For questions 31 to 42, choose the answer A, B, or C, which fits best according to what you hear. Complete your answers as you listen. Now look at Extract 1. Questions 31 to 36. You now have 90 seconds to read questions 31 to 36.
New research from the Perkins Institute at the University of Sydney claims to have found the diet that boosts FGF21 levels. One of the lead scientists on the study was Samantha Solon-Beat of the Perkins. Welcome to the Health Report.
Thank you for having me.
So what is this stuff, FGF21? I mean, it's almost eye-crossingly complicated from the look of it.
Yeah, it seems complicated, but it's actually not. And recently, there's actually been an immense amount of interest in fibroblast growth factor 21, or FGF21. And this hormone has actually recently been called this fountain of youth hormone, which we know can be influenced by diet. And the reason why FGF21 is so interesting is because high levels of this miracle hormone, as it's called, has actually been shown to play a huge role in influencing appetite, improving metabolic health and immunity, and even extending lifespan in mice.
Now, something that sounds so good to be true is usually too good to be true.
At this point, there are no adverse effects shown with increased levels of FGF21. In fact, a lot of studies are now being done to investigate FGF21 as a therapeutic target for the treatment of diabetes and cardiovascular disease.
Let's just double back, Sam. A year or so ago, we had Steve Simpson, who's the director of the Perkins Institute, talking about this 25 diet study where they studied 25 diets in mice to see if you could replicate the life-prolonging effects of a low-calorie diet, where extremely low-calorie diets in some animal species, in fact all animal species, it seems, apart from humans because it's not been proven yet, increases life expectancy or lifespan. Is the FGF21 really the heart of this matter?
We think it actually could be. Certainly in this study we've shown that a diet low in protein and high in carbohydrate is the most effective way to increase levels of this miracle hormone. And that this diet was also associated with several markers of improved metabolic health in mice.
So tell us a little bit about this study.
Well, what we actually did was performed a really large mouse study, as you said, where we took 858 mice and offered them a range of different diets to see how macronutrients, such as proteins, carbohydrates, and fats, as well as total energy, could interact and influence levels of FGF21.
And you found?
And we found exactly that we could use diet to increase the levels of this FGF21 hormone, and that a low-protein, high-carbohydrate diet was the most effective way for increasing this miracle hormone.
And what effect did that miracle hormone, I hate using that word, that phrase, but what effect then did the hormone have on these mice? Or were you able to separate the two?
We were actually able to show that the exact diet that increased FGF21 also improved things like insulin sensitivity, glucose tolerance, blood pressure, and blood lipids, even though the animals were a little bit fatter.
And how do you know that was anything whatsoever to do with the FGF21, your so-called miracle hormone, and rather than it just being an accident that it was raised too?
What we did was plotted FGF21 using the geometric framework, which is a nutritional modeling platform that helps us tease apart the role of nutrients and calories. And if you line up all the surfaces, the response surfaces in this framework with FGF21 and all the metabolic outcomes, you can clearly see that there's a specific area in the nutrient space that coincides with increased levels of FGF21 and several metabolic benefits.
And what kind of carbohydrate, and what happened with fats?
In this study, fat did not appear to have an effect on FGF21 levels. It seemed to be low protein was the primary driver, and that the highest combination was with a low protein, high carbohydrate diet.
So what does FGF21 do to the body?
And that's a really good question, and that's really the next step of our study. We want to understand how FGF21 signaling works in response to diet to mediate all these beneficial outcomes.
Do we know that there are any medications affected?
At this point, no.
It seems that it goes up with starvation, it goes up with overfeeding. There's lots of things that influence it. Did the appetite of these mice change? Do they eat more or less when the FGF21 goes up?
Oh, that's a really good question. See, this is one of the things that we were able to reconcile in our studies. As you mentioned, a whole range of literature in previous studies have shown that FGF21 is elevated in many paradoxical conditions such as starvation and obesity, high intake of food and low intake of food, as well as in insulin resistance and in insulin sensitivity. So what is going on here? Using the geometric framework, we were actually able to tease apart these findings, showing that reduced protein intake is the primary driver of FGF21.
Okay, so what happens in mice does not necessarily happen in humans. How do you know it makes any difference at all in humans?
Oh, I'm glad you said that. We've actually published work just this year showing that FGF21 levels in humans is also increased by a low-protein, high-carbohydrate diet. And of course, this is really exciting because it tells us that the work that we do in mice can be directly translatable to humans.
So is there any evidence at all that FGF21 has the same beneficial metabolic effects in humans as it has in mice?
Yes, there is definitely evidence to suggest that high FGF21 levels is directly related and associated with several benefits of metabolic health in humans as well.
So we should put it in the drinking water then, do we?
Yeah, probably. That seems to be the case, yes.
How would it work? I mean, obviously a hormone like this is probably destroyed in the stomach. This is not something that you would give directly to people, I assume, in the therapeutic context?
At the moment, it's difficult to do chronic administration to humans. So what's happening in terms of drug development is trying to develop mimetics of FGF21 and analogs. So not exactly administering this hormone per se, because it would require chronic injections or chronic administration.
So almost nothing that's touted as a breakthrough or a miracle by scientists turns out to be so. What are your modest expectations of FGF21 in humans?
Well, in humans, we actually think that FGF21 is extremely promising. We think that, at least in humans, we've shown that FGF...
So a treatment for type 2 diabetes?
Absolutely.
That sort of thing?
Yes. We've shown that humans seem to respond in the same way as mice. So this could mean that we could tailor our diets and our nutritional guidelines to generate a range of benefits from FGF21.
Is it too blunderbuss? You're describing something that sounds blunderbuss rather than targeted. You're just spraying an effect rather than targeting an effect. If you can do anything with it, it's going to be a very wide set of actions which you're going to find hard to control, isn't it?
At the moment, everyone is very interested at FGF21, but no one really knows its mechanism of action. And it seems to be a race at the moment. How does it work? What turns it on? What switches it off? And what can we do to find out more about it? So at this point, I think it's a really hot topic and everyone's racing to find out the answer.
And you hope you'll be first.
Hopefully.
Sam, thanks for joining us on the Health Report.
Thank you so much.
Samantha Solon-Beat is a researcher at the Perkins Institute at the University of Sydney, and on our website we'll have a link to our previous interview on the diet and longevity study.
Now look at extract 2.
So we are going to the second extract. Right.